Item number 7. Insert 5 arithmetic means between 8 and 26. This means that we have to place 5 numbers between 8 and 26 so that the resulting 7 numbers will form an arithmetic sequence. For now, let us represent the 5 numbers with blanks. So, let's start with 8 and then followed by 5 blanks. The last number is 26. Now, since the 7 numbers must form an arithmetic sequence, we need the common difference. So, let us use the formula for the nth term, which is a sub n equals a sub 1 plus n minus 1 times d. So, 8 here is a sub 1. And then, of course, since there are 7 terms, the last term is a sub 7. Okay. So here, n is equal to 7. And then the common difference is unknown. Now let us substitute the known values. We know that a sub 7 is equal to a sub 1 plus 7 minus 1 times d. So a sub 7 is 26. A sub 1 is 8. This is 6d. And then rearranging, we have 26 minus 8 equals 6d. 26 minus 8, that's 18. So that's equal to 6d. Dividing both sides by 6, we get d equals 3. So the common difference is 3. Now we can determine the 5 numbers in between. So starting from 8, we add 3 to get the second term. So 8 plus 3, that's 11. 11 plus 3, that's 14. 14 plus 3, that's 17. 17 plus 3, that's 20. And 20 plus 3, 23. So these are the 5 arithmetic means that are required by the item. Item number 8. Compute the sum of the first 100 positive integers exactly divisible by 7. Let us list down first the first few terms of the sequence. So the smallest positive integer that is divisible by 7 is 7. And then the next one is 14. The next one is 21, and so on. So here, the common difference is 7, clearly. A sub 1 is 7. And n, the number of terms that we are adding, is 100. So we can just use the formula S sub n equals n over 2 times 2a sub 1 plus n minus 1 times d. Plugging in, we have S sub 100 equals 100 over 2 times 2 times 7 plus 100 minus 1 times the common difference 7. Okay, so we have 50 times the quantity 14 plus 99 times 7. So we have 50 times 14 plus 693. This is equal to 50 times 707. Multiplying, we should get 35,350. So this is the sum of the first 100 positive integers exactly divisible by 7. Item number 9. Compute the sum of all integers between 100 and 800 that are divisible by 3. Alright, so like what we did in the previous item, let us list down a few of the terms. The smallest positive integer between 100 and 800 that is divisible by 3 is 102, followed by 105, and then by 108, and so on. The largest is 798. Now, obviously, we have a sub 1 equals 102. Common difference equals 3. However, we don't know the number of terms. Now, let's determine first the number of terms before we determine the sum of all these integers. We can use here again a sub n equals a sub 1 plus n minus 1 times d. So a sub n, the last term is 798. A sub 1 is 102. 102 plus n minus 1 times the common difference 3. Now let us rearrange 798 minus 102 equals. Alright, so here I will not distribute 3, although you can do that. So what I'm going to do is just retain this one, because after this line I can just divide both sides by 3. So this is 696 equals n minus 1 times 3. Alright, so instead of distributing the 3, I can divide both sides by 3. So 696 divided by 3 is 232. So we cancel this. We have n minus 1 here. And then placing negative 1 in the left side. So we have n equals 233. So the number of terms is 233. Now we can use the formula for the sum of terms. Take note that the longer formula is s of n equals n over 2 times 2a sub 1 plus n minus 1 times d. However, we can use here the alternative formula given by s of n equals n over 2 times a sub 1 plus a sub n, because the last term is given here. So we have s sub 233 equals 233 divided by 2 times a sub 1, 102, plus a sub n, 798. Simplifying, we have 233 over 2 times 900. And then let's divide first 900 by 2. That's 450. And then 233 times 450 is equal to 104,850. Alright, so that's the sum of the integers between 100 and 800 that are divisible by 3. Item number 10. A theater has 25 seats in the first row and 30 rows in all. Each successive row contains one additional seat. How many seats are in the theater? Okay, first row contains 25 seats. The second row contains 26. The third row 27, and so on. So a sub 1 is 25. Common difference obviously is 1. Number of terms here is 30, since there are 30 rows. Again, we will use the formula S sub n equals n over 2 times 2a sub 1 plus n minus 1 times d. So S sub 30, the total number of seats, is equal to 30 over 2 times 2 times 25 plus 30 minus 1 times the common difference, 1. So this is 15 times 50 plus 29. So we have 15 times 79, which is equal to 1,185. So there are 1,185 seats in the theater. Item number 11. How many terms must be added in an arithmetic sequence whose first term is 11 and whose common difference is 3 to obtain a sum of 1092? So a sub 1 is 11, d is equal to 3, and then number of terms is unknown, but S sub n is given, which is equal to 1092. Obviously, the formula that we're going to use is S sub n equals n over 2 times 2a sub 1 plus n minus 1 times d. Plugging in the values, we have S sub n equals 1092. So 1092 equals n over 2 times 2 times 11 plus n minus 1 times 3. We have 1092 equals n over 2 times 22 plus 3n. So I'm gonna distribute 3. So 3n minus 3. 1092 equals n over 2 times 19 plus 3n. Now I'm going to cross multiply or multiply both sides by 2 so that we can cancel this denominator. So if we multiply both sides by 2, we have 2184 in the left hand side, and then here we have n times, I'm going to rearrange this, we have 3n plus 19, and then if you distribute the n, we have 2184 equals 3n squared plus 19n. So I'll put the constant in the right side. So I'll have 3n squared plus 19n minus 2184. Right? Now, we can factor the left hand side. This is actually 3n plus 91 times n minus 24 equals 0. So 3n, either 3n plus 91 equals 0 or n minus 24 equals 0. Obviously, we cannot take the first one because this one is the same as n equals negative 91 over 3. We take the second one, n equals 24, since we are talking about number of terms that must be added, and it's always positive, right? So n equals 24, meaning we need 24 terms in order to have a sum of 1092.